Hello and welcome to The Future is Spoken, produced by the Digital Assistant Academy. This show accompanies the Digital Assistant Academy's course entitled Voice Interaction Design. So now you've created an AI, the work is done, right? Wrong. Monitoring and optimizing the data from voice analytics and AI performance is one of the biggest factors in progressing your solution from good to great. In this episode, Phillip Hunter, founder of CCAI Services and a member of the team that launched Amazon's Alexa, talks us through the importance of voice analytics and the steps to optimize performance to ensure success. Hello, Phillip. Welcome to The Future is Spoken. How are you today?
Thank you. I'm really good, Liam. Thank you. It's great to be with you, and excited to chat about what we're going to cover today.
Yeah, thanks for being here. So for our listeners, Phillip Hunter is the founder of CCAI Services, which stands for Conversational Collaborative AI Services, through which he has helped hundreds of companies during billions of customer interactions. And they've been able to improve performances by triple-digit percentages and added millions of dollars to bottom lines. Phillip is a pro when it comes to strategy, design, and optimization for AI-powered automation, and conversational and collaborative AI. So, Phillip, tell me a little bit more about yourself. Who are you? What do you do? And how'd you get here?
Yeah, so I've been living in Seattle for a little over 8 years now, and moved up here for a job with Microsoft, and then spent some time at Amazon, and of course during that time worked on Alexa. But the road to getting here started back in the early 90s when I needed a job, and had been working in one field, and a friend of mine called about a developer job at a local hardware software company, and so I got that job, and that happened to be in the interactive voice response area of contact center support, and it turns out that I was pretty good at it. And a few years later, that company started integrating speech recognition into its platform. Right around 95, 96 is when the technology became really in a suitable form to be integrated at the basically in industrial grade personal computers. And that was really the start of where we are now with digital assistants. It was this large grammar speech recognition systems where we could begin to build early versions of conversations with computers. I stayed in that field through about 2011, 2012. Off and on did some other things, including building tools for those sorts of applications, and doing a lot of different types of professional services and consulting work, et cetera, et cetera. And then in 2012, starting in 2012, 2016, I took a little break from that space. The contact center space can be challenging to work in for various reasons, although it is fascinating and has provided us with a lot of learnings over the years about what we need to do with conversational AI. But I did some work across the broader UX design, user experience design field inside of Microsoft, and then I also worked for a couple of years at AWS across many of the services that they provide, and really dug into product design and developer tools, and focusing on complex systems, things like that, all of which gave me a lot more appreciation for software infrastructure and things that are really crucial at this stage of machine learning and artificial intelligence, cloud platforms, et cetera. Anyway, to bring this to a close, during my time at Microsoft, I worked on early versions of Cortana, which is exciting. And Siri came out. We all were very interested in how Apple had built that. And then in 2016, after I'd been at AWS for a couple of years, I got tapped on the shoulder to join the Alexa Skills Kit, which is the developer-focused program that has led to hundreds of thousands of skills being developed, many thousands released, and then also was one of the pioneers or founding members, I guess, of the Amazon Blueprints team, which was the first no-code tool to create Alexa skills, and that's been really successful too. Since then, I've worked at a couple of startups and broadened my focus to look at chatbots over the last few years as well. And now I run CCAI and just try to keep that message going about what good conversational AI is and how we achieve it.
Very cool. So it sounds like you are really a veteran of the industry. You've been there for quite a long time and jumped around a number of the kind of landmark, conversational AI tools that are out there today.
Right.
So the topic of today's discussion is focused mainly around analytics, voice analytics, and performance optimization. So just to get started, why don't you tell us what are voice analytics?
Yeah. So there, like with any software, there's a lot of things that you should be doing early on before anything is coded. Getting your strategy together, understanding users, determining business outcomes that you're trying to achieve, going through design, which should include iterations through usability testing and all sorts of things like that. Ultimately, though, the goal of every software project is to go live. And like most software, conversational AI systems need to be able to display how well they're doing. In other words, you want to understand performance. And because many of these systems are built to achieve something specific, whether it's an Alexa skill that's looking at engagement and monthly usage, or it's a contact center application where they're trying to resolve problems or handle customer service inquiries, things like that. Almost every serious voice application and conversational chatbot has some sort of outcome that's seeking to be achieved. And the only way you can know that is by looking at the performance of the system. And so when you're thinking about voice analytics, what you're looking at is basically a set of nested metrics that indicate the various parts of performance. At the highest level, there's whatever the application was built to do. So you determine something like I said, engagement or resolution or ongoing usage, or maybe you're looking for acquiring new users. There's multiple high-level metrics that might make sense. Now, but those, to really understand how the voice system is supporting that, you have to break those down into things that are particular to the voice system. So things like engagement, monthly growth, monthly usage, all of those things can be looked at as part of a website, as a part of a mobile application, lots of other things. So what you want to do, though, is start to break that down and say, okay, how do the different aspects of the voice application support that particular goal, especially if we see outcomes that aren't being quite achieved yet, meaning we aren't meeting our goals or not hitting targets yet. And so voice analytics is about looking at that breakdown level of saying these specific actions across these specific tasks around and how is recognition working during each of those? Are we seeing any recognition errors? Are we seeing users having trouble or getting confused? And then what is our indication of what might be causing those problems? And so there's a lot of detail there that we can get into in a minute, but the basic idea is you've got your high-level business metrics, and you want to relate those very clearly to the lower-level functional metrics of the voice application, including how well recognition is working, and start to understand what's happening at that level that can be used to improve the high-level metric that you're pursuing.
Very cool. And so, in terms of performance optimization, what might be measured in that sense? And what are some methods to optimize performance? And even what would be a reason to kind of focus on performance optimization for this voice analytics, or using voice analytics?
Yeah. So, all of us as professionals, building applications, designing applications, we like to think that when after we've decided our strategy and our design tactics and how, maybe we've picked a persona, or we have done a really good job identifying users and what they are after and how they want to interact with the system, we can do the best job possible. And all of us like to think we are doing the best job possible. The thing is that even if you do a great job, there are always things that you didn't anticipate. This could be user behaviors that weren't detected before the design was finished. It could be environmental conditions in which the users are using the application that you didn't anticipate being true. It could also be just that the way models were built or the way the application logic works, it's something that just got missed, or could be that something wasn't done as well as it needed to be for that particular situation. And to a certain point, it doesn't really matter. The reality that I'm pointing out is that there's almost always something that you need to address once you go into production. And the best teams know this, and from earlier in design and development, they are plotting out how do we make sure that we understand how the system is working, and that way we can either prove that it's working great, which is obviously what we all would like to do, or we can show where the opportunity is to improve performance. And one last thing about improvement is sometimes we design for a certain set of functions or features. And in the process of doing that, we might even miss opportunities that we didn't think were there. And so it's not necessarily a problem with performance. It's that we didn't, dream big enough, if you will, about what the system could do and what users wanted to do. And we might have an opportunity to expand the functionality or expand features and gain even more success toward our bigger goals. So the idea is, whether or not you firmly believe that you have done everything possible and your system is going to really do a great job out in the wild, or whether you are more realistic and understand that no one is perfect and we always have to tweak things once they go into production. The point is that before you go into production, you want to have the right measurements in place so that you can understand the metrics that matter towards performance. So let's just pick one thing, and I'll go with resolution. So that's usually pretty clear. So resolution is the idea that someone is typically calling into a call center or a contact center. They reach an automated system, and let's just say banking, because it can be let's say a banking and a credit card system. So if I'm calling one of these systems, I might want to know something as simple as, did a deposit occur? Maybe maybe somebody was sending me money, or some other thing. So I might want to know, did a specific deposit occur? Or someone else might be calling about a charge to a credit card that they don't recognize, and maybe they want to dispute it, or they might even be wanting to report fraud. Now, all three of those situations are fairly straightforward to automate. They also, though, require some amount of information gathering from the user. and they require going to the back-end information system to understand what's happening in a specific account, and then letting the person know what is happening and what they can do about it, if anything. So if, in my mind, as a user, I care about this deposit. What I really care about, though, is I want to have money in my checking account, right? So that just getting the confirmation is part of my goal, and it's an important part. But I have a bigger goal, and maybe it's because I want to make a purchase or some other reason. Obviously, if I don't recognize a charge, I either want to find out why it's there, or if it's fraud or some other mistake, I want it taken care of. And again, that's the immediate goal. My bigger goal is I want to know that my finances are secure. I don't want to be victimized. I don't want to be basically stolen from if somebody has charged something to my account and I have to pay the bill. So resolution in these scenarios is it's really kind of there's a single part which is very measurable, like, did the user's request in the system, as far as the system understands it, gets taken care of. The user is interpreting it a little differently, so they're looking at that, but to them also the problem gets resolved. So we're going to take the first part, which is easier, is did the system do the right thing, and how do we know that? And so here, so resolution then is made up of a bunch of different things like that. So in a banking system, it could be, like I said, you want to know if a deposit has occurred, you want to know your balance, you want to make a transfer between accounts. There's all sorts of things that people do in typical banking systems. And then with credit cards, there's also, when's my next payment, or I want to dispute this charge. Again, multiple sorts of things that you can do in these systems, all of which have an end point, and that's what we consider resolution. Now, in a lot of cases, just for comparison, in a lot of cases, you'll find contact centers that are focused on containment. What they mean by that and how it's different than resolution is it's not so much whether someone gets something taken care of, it's that they stay in the system and they don't get to go to a human agent, which costs more. Now, in some cases, in some discussions, you'll find that people don't draw much of a line between containment and resolution, but I contend that resolution is actually the more important thing, because that usually leads to a satisfied customer, and that's actually what produces customers who don't want to talk to a human agent, is that the system takes care of what they need, actually, rather than them feeling sort of out in the cold about whether what they wanted actually happened. So with resolution, you're typically looking at, to measure it properly, you're typically looking at several steps in a system like a banking system. You have so in these orders can change a little bit. So sometimes you could start with intent capture, meaning finding out what the person wants. Sometimes you could start with authentication, which is giving some sort of sign-in credentials. Typically, I won't go that direction. So one of those two things usually starts the interaction. Then, depending on what information is needed to pull up the request or to fulfill the request, it could be one or more questions that the user needs to answer in order to complete the resolution. So just in the case of the credit card potential fraud, they might start off by saying, I want to dispute a charge, or I don't recognize a charge on my card, or I think someone's using my card. So all of those are variations on, I see something in my account that I don't think is correct. And so once the authentication happens, which can, depending on the bank or the credit card company, can happen in different ways. Now we have to narrow it down to which charge are you talking about. So let's assume, like most of us, you're a fairly active user of your credit card. So over the past 2 weeks to a month, you might have made dozens of purchases using that card. And so now the system needs to find out which one are you talking about. And there's a few different ways. Someone might be able to say the exact dollar amount, or maybe they might say the date that it happened on, or you could hear a list of transactions and you could say it's number 3, something like that. But there's got to be some way of identifying which thing you're talking about. And then, of course, once that's identified, then there's the final step of confirming, okay, you want to dispute this, and whatever the mechanism the bank has to satisfy that occurs. And then, the person determines, okay, this is taken care of. Now, along the way, as you can probably imagine, there's a number of speech recognition events that have to happen there. There's also sort of a narrative to the story of where I'm saying what I want. The system tells me what I have to do to get it. I have to cooperate with that. And then the system has to do what it's supposed to do. And then it's got to tell me that this has been completed, right? So there's this functional set of things that we care about of, did the recognition happen properly? What if it didn't? What happened? How were we able to get the right information from the person? Did we successfully look up the information and validate it, et cetera? At the same time, there's this sort of emotional journey that the person is on, starting the call with some uncertainty or maybe even anxiety or irritation, frustration. Something has happened that I'm unhappy about, and now I've being sort of forced to put my trust in this automated system that's going to take care of it, or it says it's going to take care of it. How do I know that? How do I feel about that? All of this sort of thing. So I outline all of that to say these are, this is sort of sketching out the picture of the situation that we have to look at to understand whether resolution is taking place successfully. So we definitely have to have our metrics in there, and we might say from this particular interaction, like, oh, look, the person got to the point in the application where it says, resolved. Now, if they did get there, we want to validate that. We want to make sure early on in production that that's really happening. And the reason is not because we might have done something wrong. We just want to, it's really like, it's just due diligence, right? You built the system to do something. It appears to be doing it. How do you make sure? And that way, if you're building the system for, if you work at the credit card company, then you want your bosses to know that you built it right and it's working right. If you work at on a platform or some other technology provider, then you have a client who wants to be shown that, oh, this is working correctly. And of course, then if it's not working, if resolution isn't happening to the degree that was the desire of the project, then you have to figure out why. So in either case, you need a set of metrics that are going to help you explain performance. So it's not so. I know I've talked for a long time straight here, but one of the historical challenges we've had with these systems is that we didn't build in the right metrics at the beginning, and we counted on certain things happening, but it was just sort of wishful thinking, right? It's pretty easy to tally these. We think of users who always cooperate. We think of users who are always paying attention. We think of speech recognition systems that are performing according to the accuracy rates published by the vendor. We think that designers and developers have designed the best possible experience, and the developers have built it in the best possible way. So, and I'm not casting doubt on anybody who's trying to do all of those things, or that, I'm not casting doubt on the idea that there are cooperative, attentive users out there. But I am saying that things do go wrong, things do get missed. Not everybody does the perfect job every time. And so it's the wisdom that I'm trying to get across here is that we used to wait until there were problems to start to analyze them. And then we would discover, we don't have the data to track that problem down. And that was wrong. That's like a miss in the software industry. And it happens all over the place, not just voice applications or conversational applications. And so what we've had to start learning to do is to say, okay, if we want these certain outcomes, if we're after these certain numbers, we need to make sure that we're capturing the data from the first moment of usage that will tell us whether those numbers are getting hit. And so we have to build in data capture, and we have to, and that actually goes backwards to say, okay, well, now we have to have a data model. We have to understand what's driving our metrics. How do we know that we're capturing them? How do we know that they're captured accurately? I've worked on systems where data was being captured, or I've worked in environments rather, where data is being captured by multiple systems and it didn't always line up. Some data was being captured in a back-end system, some data was being captured in the application, and those didn't line up. And so it's really important to work through those sorts of things before the application goes into production. Because once you go into production, you are on a live burner. You are over the flame. You are in the mix, and you are not going to have the luxury of sort of hashing through what's the best way to capture this data and let's have discussions about this. No, you're going to be in more like an emergency situation where executives or clients are unhappy, and you are you've got a target on your back, and you're being told, fix this sooner rather than later, and or else, whatever the or else is for you. So it's a lot better to be working on your data model before you're in trouble. And it's a lot less wise to be trying to retrofit a data model into an application because you discover there probably is trouble, but you're having a really hard time understanding where it is and what to do about it. So what I've outlined so far, before we get into how does optimization happen, or how does performance assessment happen, let me summarize that. You've done your due diligence on research, you've done good design work, you've done good development work. Along the way, you needed to come up with a data model. You needed to design and build that into the application so that you understand, where does resolution happen? How do you know that it's tracked by, across speech recognition events, across things like intent capture and entity capture, that it's communicating with the back end properly. So all of these things are things that you need to be taking care of before you go into production. Once you're, and of course, during quality assurance testing, user UAT, whatever it is you're doing in your particular software methodology, you need to verify that things are being captured, they're written to the right data tables, they're available in metrics. You need to make sure, metric dashboards. You need to make sure, if you've got multiple data sources, you need to be making sure that they're agreeing with each other and that they're all capturing data consistently. All of these sorts of things are really just part and parcel of the responsibility of building these systems well, especially when they're aimed at, achieving some level of commercial success. And so once you've got all that done, then once production hits, you can do the next set of necessary steps, one of which I already touched on, which is whatever the system performance is, whether it's deemed to be on target or off target, you want to validate that your data is producing those results accurately. So before we even make a judgment about we're hitting our numbers or we're not hitting our numbers, we need to say, let's validate that the performance we see is actually what's happening. And so I'll pause there to see, like if you've got questions or anything, but then I'll continue into the next part.
Yeah, I think it makes a lot of sense, and it sounds like it's not unique in the sense that you need to expect the unexpected, and you need to prepare and make sure that you're doing your due diligence and not just make any assumptions at any point along the way, and make sure to keep in mind that, like you said, there's not always going to be the perfect patient customer that's going to be on the other end of the line helping you figure it out and make it the best solution possible. They are trying to get something, they're trying to get something done, they're trying to accomplish something, and they're not there to help you test. They're they're trying to actually use your tool that you've created.
Yeah, they are not your guinea pigs. Yeah, exactly. They are not, they're there to be served, to be taken care of, for their request to be fulfilled. And, it's what you're trying to do is give them that a successful, positive experience. Yeah, exactly.
Yeah, that makes a lot of sense. So then I guess the next part would be the actual optimization of those analytics that you're now discovering, because now that you were able to implement that information, the next step would be the optimization and learning from that information, right?
Yeah, exactly. And so you want to take a look at, are we hitting our numbers? And if we're hitting our numbers, certainly you might say, well, maybe we set our numbers too low, because it's fairly rare to hit your numbers right out of the gate. But maybe you didn't set your goal quite high enough. Maybe you've got reason to say, oh, we could aim for something even better. That's a great situation to be in. It's not the most common situation, as you might imagine. But so most of the time what we're doing is looking at a situation where we're not hitting our target and it's not immediately clear what's happening. And so there's two steps there. One is diagnosis. So what's happening that we're not hitting our targets? And then there's a separate, and it's really important to get this right, there's a separate step of saying, what should we do about it? A lot of teams, especially teams that are building voice applications for the first time, are tempted to look at the symptom of what's happening. So let's say a particular interaction is running into no matches, which is where someone says something and the system doesn't recognize it. And they're tempted to look at that and right away think, oh, recognition problem, which is most often a problem with the language model, the underlying model of what's trying to be recognized. But sometimes it's a problem with acoustic signals or settings in the system, things like that. But what I'm getting at is that it's really critical to analyze each symptom with a more holistic perspective and not just say, oh, look, a no match automatically equals recognition issues. It's really important to take a step back and say, well, let's look at it from all the possible things that could cause that problem, and let's make sure that we're isolating the right one or ones. So there's this separate step of diagnostic. So there's a separate step of saying, okay, let's figure out what's the best way to fix that. And it could be a multiple approach, solution, but what it's almost, or what a lot of teams get into trouble with, where they just get into this loop of like just almost, throwing spaghetti solutions against the wall, is they react, they fix one thing, and then they discover the problem gets worse, or the problem doesn't get better, and then they're left figuring, then usually they're pursuing that particular solution deeper, or they start to give up and say, oh, well, people just don't know what to say, or they're not using it right, or they'll start to do user blaming, which is has been a big problem across the software industry. So optimization, though, is really about taking a much more measured and robust and rigorous approach, and this, I can tell you, leads to successful correction of these sorts of issues more often than not. And so, so diagnostics, and then say, how do we fix it? And then, of course, there's a third step, but it's really the loop there of saying, okay, we've applied the fix. Now we're going to go back and look at our metrics again and basically re-diagnose and say, did we fix it? It's sort of like a doctor. Is the patient better, or is the patient not better, or is the patient worse? And so, of course, if we've done our job well, most of the time, the diagnostic looks better, and we can start to focus on other things, like maybe expanding the feature sets or whatever. But that can only happen once we have the right kind of performance we want.
Very cool. Very interesting as well. I think this is like the key to kind of turning an existing product from launch into, the perfect dream that you're maybe not always perfect, but the goal at the end can't come without this performance optimization that's coming through, the testing and the troubleshooting. But it also goes back to the original point that you made about voice analytics, that you don't know what you don't know. So it comes with setting up the correct analytics and then using those to optimize your performance throughout the launch and the post-launch process of your tool.
Yeah, exactly. So I'll dive in a little bit into more detail there, and I'll give a little bit more historical context of why analytics and optimization are sort of different than they were, when I started in this business, or even 15 years ago. So when I got started, we had metrics, but we used to look at them on an event level. So we're trying to recognize how well are we recognizing account numbers, or how well are we recognizing monetary amounts or dates, or a menu of choices. And the thought was that if we optimize at that local event, then there would be a sort of a outward cascade of positive reaction that would make the whole system better. And that's not completely wrong. If you make recognition better in one spot, especially a heavily trafficked spot, in general, the system is going to get better. The problem is that performance of something like resolution is hard to clearly tie to one recognition event. And so so what you might see is, okay, look, our account number recognition is better, but our resolution rate didn't change. So what's going on there? So back about 20 years ago, some of us started talking about, well, we need to measure these vertical spaces of where we're doing these individual recognition events, but we also need to measure the longitudinal the journeys that people are on. And so what do they want to do? What do they have to do it? Do they get to an endpoint that looks successful? And so we have to start looking at, okay, for everybody who wants to dispute a charge on their credit card, everybody who wants to do a transfer or find out if a deposit was made. And we have to start isolating it by the task or the request that the person has, and then see, is that number of achieving resolution, is that number correct? And then we can say, so we might say, let's go with our disputing a charge thing. We might say disputes are too low. We need them to be higher. There's too many people having to go to an agent, and we believe that they're going to those agents unnecessarily. So we want the system to perform better there. And now that we've got this isolated, we can say, okay, what's happening in the charge dispute journey that's going wrong? But if we were just focused on account number, we're not necessarily doing anything to address the dispute path, because the problem may not be at the account number. And so until we've done this vertical and horizontal analysis of both event performance, but also journey performance, then we can't really, say that we're going to have the right effect that we want. So diagnostics first is about saying, okay, we used to do the old way of just measuring like accuracy and event performance, and we used to sort of think one-dimensionally about what the potential problems were. But now we're going to think in at least two dimensions here, and we're going to say we want to know event performance, and we want to see if anything's sticking out there and there's a problem. But we really need to focus on journey performance, because that's where our business outcomes are realized, is by achieving those journeys properly. So diagnostics then becomes at least a two-part thing first, of where we're saying, okay, what's our event performance, but also what's our journey performance? And then if we see a problem with either one of those, we can dive in. Now, I contend that the journey performance is more important because it's closely aligned with business outcomes. And you can argue all day with a client or your boss that, account number recognition accuracy is great. And they could still look at you and say, yes, but we're not seeing the resolution rates that we need to. Once you do both of those, you can start to use them to line up where the potential problems are. So you've got a horizontal journey, and you could say, well, account number recognition looks pretty good. And then, narrowing down the dispute, or understanding that they want to dispute a charge looks pretty good. It's when we get into understanding which charge or which set of charges they want to dispute that we start to have drop-offs or escalations. There's a couple different things we might look for. We might look for people who are giving up and just exiting the application prior to resolution, or we're looking for people who are escalating, transferring to a human agent. And so let's just say in our particular scenario here that we discover that we're using a list presentation method of the design to say, here are your last 5 accounts, or last 5 charges. Which one of these is troubling you? And let's say we're having, a lot of confusion there, where people are responding with that one, or the third one, or the one on the 17th, or the one for 4348. And so, what we're getting there then is this wide range of inputs that maybe we didn't design for. Maybe we just designed for them to say, it's the third one. And so now then we can say, oh, look, okay, we found the place where we have the most escalations or transfers and the most abandons. And what we're seeing is people not listening to the instructions that we give them about, what to do. And instead they're doing what? They're being human, and they're using natural language to express what they find meaningful. And so at that point we have now we have our diagnostic, right? So we see what is it that where's the trouble? What are we falling short on? And what are the symptoms of that people are using language that we didn't intend or that we didn't anticipate. So now we can move into the solution part and say, okay, what do we want to do about that? Now, essentially a handful of things that can be used in any application. You can look at recognition accuracy. You can try to tweak that. You can look at recognition constraints, like what is the set of things that we're trying to recognize, and is it the right set? We can also look, though, at wording. Are we giving them instructions that they find clear? We can also look at task sequence. Are they ready to do this particular step, or is it too early or too late in the task flow? Or did something happen prior to this point that maybe set an expectation in the user's mind that the rest of the flow doesn't live up to? And so we're looking at things like, what is trying to be, what are we trying to recognize? What are the instructions given? Characterizations of the input that we're getting from users. And maybe we go talk to the agents that they're, being escalated to and say, what are they saying to you once you start talking to them? Do they say things about the system, or do you understand their request in a way that we didn't anticipate in the design of the system? And so we're, like a good doctor, we're really trying to take this holistic view of, what is it that's we've isolated like where it hurts, and we've isolated that we're not seeing somebody isn't able to run like they used to, but now we need to say, okay, what are all the things we need to look at in order to know how to fix it? And so before we start prescribing medication, we have to say, let's get really clear on what the right solution is. And this is the crucial part of the optimization process, because you're taking that step to say, how do we make it better? And how can we have some level of confidence or even certainty that we're going to make it better? Now, and that's really where the interaction between your designer, your developer, your data scientist, maybe a user researcher, the product manager, all got to put their heads together and say, okay, well, how do we make sure we get the right outcome? So we've already spent a lot of time, a lot of money, and a lot of effort, and we're about to change something. How do we make sure that we change it the right way? And that gets into, what's your process for coming up with solutions and brainstorming and things like that. But the biggest thing I want to encourage people to do is just take that holistic look and really analyze the different things and say, and ask a lot of what if questions. What if we changed this? What if we tried this first? Or what if we did this first? Or what if we got something wrong in the design process? How do we fix that? Questions are really, really useful here for, how do we get to this place, and how do we get out of it? Now, mechanically, I'll raise that there's a number of traditional software methods that serve us really well here. One is once we have solutions, we should experiment with them. So A/B testing is really important here. Don't go all in on one solution and then just implement that and then just hope for the best. Like, roll it out, small population, and do some testing, have it take enough calls that you can do some statistical comparison, but, mitigate the risk, manage the risk. Don't get yourself into a worse situation by just throwing solutions out there. The other thing that's important here is, to have buy-in across the team. Like, make sure that when you're gonna try a solution that the team is comfortable with in general what we're trying, and of course there are going to be disagreements and things like that, and so you've got to work through the numbers here. One thing that I also I really emphasize getting the numbers right earlier, and through those numbers I can say that sometimes the insights you have or the insights you get from those numbers are not the ones you initially expected. So I worked on optimizing a system last year that the problem really ended up being in the intent capture part, where we were getting a broader range of inputs around certain intents that we anticipated. And early on, I was asked, well, what if we just optimize the journey after that intent? and I was able to run the numbers, and I was able to say it actually it doesn't matter enough. Like, we could definitely improve the post intent capture resolution rate, but it actually doesn't achieve the business goal. So we even though we may want to make improvements there, what we have to do is capture that broader range of inputs. And in order to do that, we had to change prompting, we had to change some ordering of questions, and of course we had to improve our model as well. And so we really needed all three of those things to be put into place. And we worked on multiple variations of that. We had some disagreements. We ended up rolling out 3 alternate paths to try to get something better, get better performance. One of those ended up outperforming the rest by a significant margin. And so, we pulled a couple of the alternates out to narrow it down. We let that run for a little bit longer, and it still kept outperforming. And so finally, after several weeks, maybe even more than a month, we finally rolled to 100% of the solution that's performing better. And then across the board, our numbers shot up significantly. We saw around an 80% improvement in performance. But that was, through this careful analysis and really taking the holistic view and doing the math and making sure all the data was being captured properly and all of that kind of stuff. And so, I want to, I'll re-emphasize that I've got to have the right data. You've got to make sure that the measurements, the metrics that you're getting are actually accurate and appropriate. You've got to do the right kind of diagnostic to really narrow down where the problems are. And then you've got to make sure that the solutions that you're exploring are ones that are going to do the job, rather than, and then you've got to roll them out in a way where you can verify whether they're doing the job before you commit to it 100% in production.
Wow. Yeah. So it sounds like really the analytics and the performance optimization are so key to turning any sort of conversational AI from bad or good to turning it into something that's really great. So yeah. Just before here we start to wrap up a little bit, I kind of wanted to get a little bit more kind of big picture, just industry wise. I had a few questions. I was wondering, what are some of the ways that you see conversational AI being utilized in the future that might not be obvious to those outside the industry today?
Yeah, so we've already gone through one huge change that most people who are working in conversational systems don't fully realize. But so up until Alexa, Google Assistant, Siri came out, so the time span of like 2011 through 2014, speech recognition was already handling billions of interactions a day mostly through contact centers. Some of us may have used, little speech recognition things on our phones, or maybe we use dictation like Dragon systems or whatever. But the interactions that were being had through these customer service, contact center applications, were, at this massive scale, and still are. The numbers are still overwhelmingly in favor of people, people call more than they email, they call more than they chat, they call more than they go into a branch or whatever. But so we've had that going on for a while. That started in the late 90s. And then 2011, 2014 came the rise of the voice assistant. And now we moved from speech just being used almost purely in a very transactional contact center sort of way to becoming part of entertainment and smart home management and even just, sort of having fun playing games, or just finding out about the news or the weather or the traffic or whatever. So now, what's changed is these devices that are in our homes and our offices or just our spaces, and they become a little bit more intimate. And so, and meaning that they're close by, they're, listening all the time, for their command to kick off. But they, and so they've become useful, but they're still at a very command and control level, right? Turn off the lights, play this music. What's the weather? How does my commute look? And there's a lot of usefulness in this sort of single shot activity that we do with them. And then there's some things that are a little bit, more than that. So there's some good games out there, everything from something that almost everybody would know, like Jeopardy, to some adventure games where, sort of like old games where you had to like figure out as you went along, like where you were and what to do. And so and those are fairly popular as well. And so clearly those are multi-turn, not just one shot. And so there's some things happening there that have started to open up the realm of what's possible and what's real. Where I think we still need to go, though, is embedding an amount of robustness in the system that lets us figure things out with the assistant. So, and this takes a level of flexibility within the assistant to account for not everything's going to come in really perfectly well formed. And it's not just a matter of like one little word. It could be that somebody doesn't really understand or doesn't feel like they can articulate something clearly and they need to work it out. That's something we do with each other all the time, every day. And so one of the things I see these systems being able to do, hopefully in the near future, is to work with us or work for us on slightly more complex tasks. So let's say I'm trying to find the best mechanic in my neighborhood, and I'm doing something with my hands, so I don't want to look it up by searching on my phone or going over to my laptop, or let's just say I have a preference to use voice. Now, how would I go about that? So there's so many variables when you look at something like finding a mechanic. What kind of car do you have? What's the problem with it? Is it maintenance? Does something need to be repaired? What are the reviews? What's their turnaround time? Am I on a 2-week backlog? All sorts of things that come into play. And now those of us who've owned a car for a long time, we're somewhat used to that, but still, this is sort of a rare occurrence, right? Otherwise, we have a problem with our automobile. So we're not always thinking about it in the most efficient way necessarily to handle this, and we might express ourselves ambiguously or sort of roughly or imprecisely. But as humans, we're really used to that being okay, and we do a lot of negotiation and repair with each other. We use questions really well of like, oh, hey, do you know a good mechanic? Oh, what kind of car do you drive? I see you drive. You drive a European car, so I know this one who works on European cars. Or you might say, well, what's wrong with your car? Oh, I had a fender bender. I just need to get some dents. Oh, there's this great body shop down the street. So we're really good at that. And these systems can be good at that. It takes more work than currently anyone else is putting in. But we can get good at that. There are rules around, how we do those sorts of negotiation activities. There are fairly well understood domains of information there. And it's just a matter of really putting in the work. So that's really one of the big things that I see is that our systems will grow up a little bit and be able to handle transactions that are still pretty mundane, but have a little bit more complexity than, what playlist do I want to hear?
Wow, that's very interesting. I like the idea that that is somewhere in the future, somewhere near in the future. That's a very interesting point to bring up. And then I guess lastly, the question that I have is, what is some advice that you can give to someone who is new to this industry or new to voice analytics and performance optimization specifically?
Yeah, so I'll say two things there. One is when you look at voice analytics and whether they're provided by the platform or a vendor, or whether they're built in-house, make sure that you're seeing that dual perspective of the vertical sort of event tracking thing, and you'll see that portrayed on dashboards as overall accuracy or event level accuracy, or you might just see a breakdown of like theoretically correct recognitions and misrecognitions and no responses where the person doesn't say anything, etc. But you really need to look at the journey too and say, okay, well, if we're handling 30 intents, check my balance, did this deposit make it, et cetera, dispute a charge. We need to have those journeys broken down too. And so you've got to be able to take that dual look. And we haven't always done that very well, going all the way back into the old IVR days. And really, like I said at the beginning, even for mobile applications, web applications, there's still a lot of confusion around that. So you want to push pretty hard to be rigorous on that. It's something where if you're new to this, you need to go ask questions of the people who understand the speech recognition system, the designer, or maybe a designer who knows if you're the designer of this new system. The developer got to be there to usually put some data capture in. So don't be afraid of the numbers and the idea of analytics, but also don't assume that any analytics package you run into is going to actually measure the right things out of the box. The second big thing, and this is a little bit more controversial, is don't limit yourself to understanding the feature sets of the different platforms. Right now, we say the phrase conversational AI. Right now, our systems do so little actual conversational work, like just a back and forth of tell me your account number, here's my account number. Like that's such a basic little bitty thing within conversation. And there's so much more that we're not accounting for quite yet. Things like different structures of conversation, like negotiation, collaboration, resolution, repair, context management across time. All of these sorts of things are things that are not being done well or at all currently, but they will be. And so don't just study the platforms and what they're capable of today, but study conversation, study how people communicate with each other verbally. Now, obviously, we're not, I'm not at least trying to build an AI system that wants to have a beer with you and just, talk about whatever all night long. But I am trying to build systems that are effective at even more complex tasks. And to do that, I need to have a better understanding of how conversation works, not just how the technology works. Obviously, the technology has to support things, but we aren't doing a good job of understanding what the technology needs to support right now. And that really spans all of them. Google, Amazon, the small providers, none of them are really tackling that in a way that's visible to us. At least, there may be some research inside these organizations that I'm sure there is that we're not aware of. But if you're new to this, study how conversation works. And there's some great books out there. I have some on my website, CCAI services.com. I have some recommendations for that.
Great. That's some great advice. And is there anything else that you wanted to discuss, or anything I didn't ask that you wanted to bring up?
I don't think so. Just to hit the high point. The high points. Don't be afraid of analytics. Don't be afraid of the numbers. If you're not a numbers person, find somebody who is and ask questions. Try to understand. What this is about is really understanding two sets of behavior: the user behavior and the system behavior. So it's not so much that we want to we need the numbers to help us understand those behaviors, but the key thing is we're trying to understand those behaviors in relationship to each other and how we can manipulate the system behavior to facilitate more successful human behavior. So that's the highest goal there. And dive in. You're going to make mistakes. You're going to get things wrong. It's the best way to learn. And good luck.
Couldn't agree more. Could not agree more. Well, it's been a pleasure. And that website that you mentioned with the book recommendations, and that's where anything, I guess, related to your organization, it would be CCAIservices.com for those who wanted to check it out. And thank you so much for being here on The Future is Spoken, Phillip Hunter. And I hope you have a great rest of your day.
Thank you.
Thanks for listening today. Remember, you can find all the information on how to become a certified voice interaction designer, along with show notes and more, at our website, digitalassistant.academy. That's digitalassistant.academy. We encourage your feedback and questions, so be sure to get in touch by using the contact page at the Digital Assistant Academy's website. We'll include the link in the show notes. In our next episode, Renee Cummings talks about the necessity of ethics in voice design in creating a better world for everyone now and in the future.